Hi everyone, in this Rguroo tutorial we are going to do a hypothesis test for independence. So we have an example that we worked previously with the TI calculator. This time we're going to work the same problem with Rguroo. Use the table below to determine whether the choice of major and hours of study are independent at a 0.01 significance level. And then we have a table with 4 columns for major and 3 columns for hours of study. And so those two factors, major and hours of study, are what we're trying to see if they are associated. So this is a test for independence. So the null will be the two factors are independent. So we've written choice of major and hours of study are independent. And for H1, we have choice of major and hours of study are not independent. So now we're going to do a chi-squared test. So in Rguroo, the toughest part of this whole process is not really tough, but the longest part of the process is entering the data. So you're going to go to Data, click the drop down for Data Import, and choose Create New Table, because the data we have is going to be in a table format. And then we are going to use the little icons here to add rows and columns. So there are 4 columns and there are 3 rows. So the first variable is humanities, and the second variable is social science, and the third variable is business, and the fourth is engineering. And then for our rows, we have 0 to 10, 11 to 20, and then greater than 20, which they used a symbol for greater than, but I decided to write it out, but it's completely up to you. So then we're going to enter our data. So we have 68, 119, and 70. If you want to fast forward this part, I completely understand, or at least speed it up, right? Or if you're following along with me, this gives you time to enter the data in Rguroo yourself. All right, and so then we want to label our rows. So our rows were hours of study per week, and our columns were major. Variable name, the numbers inside the boxes are the number of students. So I'm just going to put number, and then I'm going to save this as hours of study by major, and hit save as. So now if I look in my data set at the very bottom, it now, or my list of data sets, I now have hours of study by major listed. So now if I want to test to see if those two factors, hours of study and major, are independent of one another, I click on Analytics, click on Analysis, and we're going to choose Contingency Table. Once we do that, we're going to select our data set, which is hours of study by major, and then you're going to pick the two factors. It doesn't matter which one you choose for first and which one is second, but you choose one of each, hours of study per week and major, and then number for frequency. I'm going to click on chi-square because this is a chi-square test, and then change my significance level to 0.01 because that is our significance level in this problem, and then preview. And so what you'll notice is first, you have the observed counts. You may notice that they have rearranged our table in alphabetical order. So instead of having humanities, social science, business, and engineering is now listed business, engineering, humanities, and social scientists. So they put it in alphabetical order. You'll also notice we have a total column and a total row. So that's nice. So what we're interested in, though, is the chi-squared test of independence. And we can see that our p-value is very small. It's 0.00001. And you can see it graphed down here. It's so small you don't even see the shading. It's such a small probability. So because it's small, we're going to reject the null. And if we reject the null, then there is not enough, if we reject the null, there is enough evidence that major and hours of study are not independent. Because remember, when we reject the null, it matches up with the alternate statement. So we found that it's not independent. And if it's not independent, that means that they actually are associated with one another. So major does affect the hours of study. Now, we got the same p-value here. We just rounded it out to, it looks like 1, 2, 3, 4, 5, 6, 7 decimal places. Rguroo rounded it to 6, but it's the same. It's the same answer either way. Okay, so let's look at another one real quick. Educational issues and museums. Do people who are interested in educational issues visit museums more often than people who are not? In 2008, the General Social Survey asked 1,499 people how interested they were in educational issues and how often they had visited a science museum in the past year. The following table presents the results. Can you conclude the number of visits to a science museum is related to interest in educational issues? So for the null, we have number of visits to a science museum and educational interest are independent. And then for H1, number of visits to a science museum and educational interest are not independent. And when we say not independent, that's the same as saying that they are related. So H1 is matching up with the claim there. So we'll see we have 3 rows and 3 columns. The columns are number of visits and the rows are how interested we are. Now, if you look at my data, I have already added the table for educational interest. So I'm going to go ahead and run the test. So analytics, choose analysis, choose contingency table. Select your data, educational interest. Factor 1 is interest. Factor 2 is number of visits. Frequency is just number. Choose chi-squared. And there we go. We get a p-value of 0.01347, which rounds to 0.0135, which is what we got right here. 0.0135 is greater than the significance level of 0.01, which I don't think I changed. Oh, no, it was 0.01 there, so we're good. So it is greater. It's actually greater than that, 0.01. 0.0135 is slightly greater than 0.01, so I call it failed to reject, although it really is borderline, because if you rounded to 2 decimal places, they'd be equal, and if it's less than or equal, you reject the null. But because 0.0135 is slightly bigger than 0.01, I'm going with failed to reject, which means there's not enough evidence to conclude that the number of visits to a science museum and educational interests are not independent, or you could replace the words are not independent with there's not enough evidence to conclude that they are related, because that's the wording they used in the problem, but you are welcome to use either one. Okay, so that is how to do a chi-square test in Rguroo. If you have questions, let me know.